I've got to say, I'm really thankful that we're all able to get together like this. Um, although seeing so many friends, so many familiar faces, of course, it would have been a lot nicer if it were in person in Denver where we could be together and, eat food and stuff like that. But this works too. So the story that I will be sharing with you is about groundwater research that we've been doing here at KBOCC. This is one of the two main research projects that I'm the director of here. They're both related to water. So um, I guess I'll get going. I have students. Every name you see on this slide after mine is a student research assistant. I know I'm speaking to a national audience here, so I want to make sure that everyone's familiar with the little part of the world that I'm from and that all of this refers to. So hopefully you can all recognize this image as the Great Lakes region, and this red square I have highlighted is what I'll be focusing on. Is you see more images throughout this presentation. This is our general area. This long, skinny peninsula that you see on the map here is called the Kiwinot Peninsula. The long, skinny water body next to it is called the Keweenaw Bay. And so we're located right at the base of that, the Keweenaw Bay Indian community. And here's a few images of what our world looks like, at least this time of year. So in any direction you could go, there's no shortage of beautiful beaches, fresh water everywhere, beautiful forests, streams, waterfalls, probably about the most adventurous topography that you find in Michigan. Not a lot of really high points, but we definitely have some interesting geology. And also a lot of wetland and swamp areas too. This image in the bottom right is basically a bog, which we have a lot of. They support a lot of important medicinal plants, among other things, some really rare species as well. So if you ask me, this is a little slice of heaven, and I'm thankful every day that I'm able to live and work here. And this is an image of our college. This is our main campus, the Wabanung campus in Lawrence, Michigan. For those of you who may be the slightest bit familiar with this area, we acquired this building and renovated it about 7 years ago, I believe now. This was the old Baraga County Hospital building. So to us, this is a pretty new and exciting development that really helped with the resources we have here on campus. So the project that I will be sharing with you is part of a grant that I got funded through the USDA National Institutes of Food and Agriculture, or NIFA. They have a wonderful program called the Tribal College Research Grants Program that I have actually currently right now 3 different projects through. This is a program that has small tribal colleges like us partner with our state's land grant institution. And the idea is to increase the research capacity of the smaller institutions like us, not only technological, but human resources as well. So everything that I'll be sharing with you is up to about the wrap up of the first phase of this project. So we did start in 2018, and our partners on this, I want to be sure to acknowledge Michigan State University Institute of Water Research. They have GIS tools, modeling capabilities, and people with expertise that we don't have here at our small college. NEHR Consulting, that stands for Native Environmental Health Research. Dr. Doug Stevens. Doug was at Salish Kootenai College for a good number of years, and he's a toxicologist. So again, we don't have a toxicologist on staff here at KBOCC or on our faculty. So another necessary partnership. And also Whitewater Associates. I'll use the word local in air quotes. They're about 50 miles away from us here in rural northern Michigan. They're the nearest laboratory facility that's certified by the appropriate state and federal agencies to do the kind of testing we need done. So they're an important third partner too that we've contracted to do all of our, to handle all of our laboratory services. So just as a broad overview of the goals of this project as we started it in 2018, our big concern was arsenic in groundwater. So that's what this is. Everything I'm going to be talking about comes down to arsenic in groundwater. Assuming everyone's aware that arsenic is a toxin. Throughout history, it's been a popular method of poisoning people, but it is naturally occurring, or at least would be expected to be naturally occurring in our area. And our goals with this project were to determine if we have potential risks of arsenic in groundwater in our area from wells. So again, rural area, a lot of people with wells as their drinking water source. That's the initial curiosity here with this whole project. And along with this, with assessing any potential health risks, we want to be able to advise the tribal leadership, like our tribal council, on if there should be a concern for tribal members, especially those with compromised health. And through the partnership with Michigan State, we're going to develop a 3D digital groundwater model that would be a really helpful planning tool. So to be able to take data points on a map that show different arsenic concentrations at different depths, and to be able to determine, is there a predictable movement of flow or maybe a predictable depth. If you think about it, that could be really helpful for anyone who might be digging a well anytime soon to know whether or not they should expect to hit arsenic at certain depths. But again, the main thing this comes down to is enhancing our research capacity, serving the community, providing student research experiences, and of course, contributing to the scholarly literature. It's always a goal. So arsenic is what's called a metalloid. You can basically think of it as a component of the mineralogical makeup that you could find in rocks and soils. And it therefore could dissolve and infiltrate groundwater supplies that wells are tapping into. There are many industrial sources of arsenic contamination. Industrial agriculture is a big one, but we don't have any of that around here. There's really nothing outside of maybe some possible legacy effects from some historic mining or something. There's really nothing around here in our immediate area that would stand out as a human-caused source of arsenic in our groundwater. So we are expecting that what we would find would be naturally occurring. But again, anyone with wells as their primary drinking water source are on their own for monitoring their water quality, right? City water sources monitor water quality for a wide number of parameters, and they're required to meet limits that are established by agencies like the EPA. But if you own a well, once it's drilled and it passes the initial test, usually which is for bacterial contaminants, residents are on their own. And furthermore, most people who do have tests done on their wells usually do not have it tested for arsenic. Usually that's the kind of test that a person would have to pay extra for. So there's a lot of unknowns, basically, as far as any potential risk in our area. Arsenic exposure, what we do know is that it can result in a wide range of human health problems, starting out with pretty much any kind of cancer you can think of. Okay, that's a big area of concern. Also, skin ailments, circulatory, respiratory problems. It can be pretty deadly. So how much arsenic is considered safe? Again, with the word safe in quotes. Um, that brings to mind another question that comes up in our area that a lot of people can relate to, and that's the topic of mercury in fish and how much mercury is safe. I mean, the state or different agencies set levels where they say, well, if you stay below this, you should be okay. But again, that's kind of arbitrary, and we all have our own sets of health conditions, our own perceptions of what's safe and what isn't. So that's kind of a really fluid question. But the Environmental Protection Agency had to pick a number somewhere, right? So the maximum contaminant level, or the MCL, that they've established is 10 parts per billion. That's a very, very tiny concentration. The good news is that's recently been lowered to 10. For a long time, they used to say that 50 was, I guess, the safe limit. Research found otherwise. I believe it was during the Clinton administration that this was dropped down to 10. Although some scholarly research out there said even concentrations as low as 5 parts per billion could cause some serious problems, specifically with the cognitive development of children. And other researchers assume that to extend to fetuses as well. So again, it varies depending on the population, but one basic concept from toxicology that I've learned is that a person's risk can basically be expressed mathematically as a combination of the dosage, or the concentration, times the amount of exposure. So in other words, how much arsenic would be in their well water and how long have they been drinking it. So that can kind of help us identify our target population here in our area, maybe to really include people who've lived in their homes a really long time. That's something that's pretty common around here. Seniors, elders who've lived in the same home and they've been drinking their water 40, 50, 60 years maybe. So we do know that arsenic has been found in our area. There hasn't been a huge amount of research that's been done. It's a bit scattered. I wasn't able to find anything recent in my literature search, so there's definitely a knowledge gap. But according to the state of Michigan, you can see in this little map image, this is Baraga County that's circled. And according to this map image, that means that the Michigan Department of Environment, Great Lakes and Energy has somewhere on their databases records of concentrations exceeding 20 parts per million. Micrograms per liter is the units that you see down there. That translates to parts per billion. So we do know that this area, there have been wells that have been found to exceed 20 parts per billion. And as a preview, I will be telling you that I'll be adding to their records. So the point is, we know that we're in an area where there is likely to be arsenic found. So everybody loves pictures, especially me. As we got going with this research, I've got a few images here of the students that were involved in our first cohort receiving training. We had toxicology workshops here on campus. We got to visit and get some training from the laboratory facility. That's what the two bottom pictures are in this image. So in our first year of this, we had 4 student assistants actively involved. They all did great. We began with a lot of outreach to drum up interest in our project, to get the word out there to the community about what we were doing. We had an informational booth, actually at 2 powwows, not just one. We had an announcement in the tribal newsletter, an article in our local newspaper. So pretty simple stuff just to get the word out there, just very, very local. in addition to spreading the word on social media. The students made some really great informational brochures, pamphlets, and things that we distributed. And as we soon found out, we benefited from a lot of word of mouth, especially between neighbors. It was pretty funny that I would end up over and over again going to somebody's home to test their water, and without even me knowing it, they had lined up several of their neighbors right up and down the road for me to go and stop at their houses too. But these were all very successful efforts, especially the article in the local newspaper. I ran a very small, I think it was a quarter page or maybe even an eighth page article, and that alone got over 100 responses. So that's one of the benefits of working in a small town. Word gets around. So this is a picture of one of our student assistants at the powwow. She's got all of her beautiful regalia on. This is Sydney Vokes. By the way, I also need to credit Sydney for making these artistic slide backgrounds you're seeing today. That was her work. So Sydney is one of the 4 students from the first cohort. They've all graduated, by the way, since then. So congrats to them. But what we did after getting the word out there was basically invite anyone who's interested to call or email me. That was the extent of the outreach. And again, there were periods where my what do the kids say? My phone was blowing up, barely enough to keep up with. So as the calls were coming in for people who wanted me to come test their water, we would go to people's homes for the sample collection. Now there were 2 different things that we were interested in learning about. 2 different possible things. One is what's in the water that they're drinking, and 2 is what is naturally down in the water that their well is pulling up from a couple hundred feet below the ground. Now that could be the same thing from one sample. So for example, if for homes that had no treatment, no water softener filtration, which is pretty common around here, then that means the water they're drinking out of their kitchen tap is right out of the ground, and that was the only sample I needed. But in instances where people had any kind of filtration systems, we took multiple samples, because in those cases, what they were drinking could be different from the untreated water from the ground. And we wanted to know what both of those values could be. So at the visits, we shared, we gave them a little overview, a little mini lesson about arsenic and health risks. We had a questionnaire for a lot of information we needed to gather, of course, an informed consent form. And after we collected samples, the students and I drove them down to Whitewater in person to be dropped off for the testing. And I'm going to jump ahead here to some pretty exciting stuff here. We're at a point again now with this project where we've paused the sample collection and we're getting into the analysis. So our original goal was to get results from 100 wells, and we blew past that very easily. We wound up at this point with 152 wells that we have data from, 21 of which we have reasons to be concerned about. So 11 of the wells tested higher than the EPA's limit of 10 parts per billion. And that includes, after me going back and doing a second test just to check for accuracy. And then aside from those 11, we had another 10 that were less than 10 parts per billion, but above 5, which again, there's research saying that even 5 should be considered unsafe. So far we have 21 wells altogether, 21 families that we have reasons to be concerned about. So we clearly confirmed that there are potential health threats in this area from arsenic contamination. I'm going to leave this screen or this page on the screen here for a couple minutes. so everyone could admire all the multicolored dots. This is kind of crude. Again, we don't have a product from our colleagues at Michigan State yet, which will actually be high-tech GPS use, but I made this map intentionally simple. The bigger and the redder the dot, the bigger the problem. So the big red dots are the highest concentrations of arsenic that we found. Again, 10 parts per billion or higher. The orange ones are the next level of concern that are above 5. Yellow dots are below 5, and the green dots means that the test came back with no arsenic detected whatsoever. So I overlaid these dots on a simple geology map from our area showing the different geological formations. One of our hypotheses was that perhaps there could be a relationship between arsenic concentration and the underlying geology. Now, before long, I'm going to be calling on my dear friend and colleague, Karen Colbert, throwing her this data set to help me analyze it. But we see that there does appear to be perhaps a pattern here, a spatial pattern. These red and orange dots, the ones that with the highest concentrations, seem to be almost all in what's called the Michigami Formation. While this Jacobsville Sandstone Formation that covers a lot of the rest of the area, the results overall look a lot lower. So we haven't run statistical tests. I am not saying that there's a relationship, but I'm saying that this is something we are very soon going to be looking into, because this, again, this was one of our hypotheses that maybe a relationship could exist. The second hypothesis would be perhaps a relationship between arsenic concentration in well depth. So far, we have found that to not be the case, but again, we haven't run those tests on our full sample size yet. So definitive answers will be coming probably this fall. And I will start to wrap this up here by drawing again back to the hypotheses. As I mentioned, we'll have full analysis wrapped up pretty soon, including the 3D groundwater model coming from our colleagues at Michigan State. I can't wait to see that. I want to also mention that I hate to say thank God for global pandemics, but something good came out of this as we, like everyone else, had to adapt to COVID. Because we had to take over a year off from planned activities that cost a lot of money, like conference travel for me and students, for example, we wound up with extra money that we needed to spend down in our budget. And so thankfully, the college president here and the project directors at the USDA loved the idea I pitched to them, which was, how about if we use the remaining money in the grant to purchase and install reverse osmosis systems for everyone whose water we found needed to be fixed, basically. And the USDA was completely on board with that. So not only did we identify potential health problems for people in the area, we are installing purification systems to solve their problems. So we are buying reverse osmosis systems. We are paying to have them installed. This is an example of what a reverse osmosis system looks like. These are the ones we're purchasing. They're called a 5-stage reverse osmosis system that fit underneath the kitchen sink. As you can see in this picture, our contracted plumbers we have, this is a picture of them installing one at one of our first homes. So this is a really good thing. It's really warming to not only be able to help people understand what's in their water, but to solve their concerns about risks that we're finding. And we have found concentrations exceeding 40 parts per billion. That's really high. And so on one hand, I feel like being the bad guy, telling them that it's not safe to drink their water. But now I feel like the good guy saying we can provide the means to solve this problem for you. So just to wrap up with some overall conclusions here, student contributions. In spite of COVID, we've had 6 paid student assistants that all 4 on our first cohort graduated. 2 of them based their capstone independent research projects that we require for the degree on their research. We had 1 in-conference presentation that the students themselves delivered. That's the images on the left and right here. This was the 2019 First American Land Grant Consortium, which was just in the months leading up to COVID. So a lot of benefits for students. And as far as going forward from here, well, we have wonderful news that I submitted a proposal to continue and expand, and it has been funded. So not only are we going to continue the work with arsenic, we're actually going to start testing for uranium and manganese as well. And this time I incorporated into the budget the reverse osmosis systems and the installation. So right now we know from the get-go that we will have the money to continue offering that service to people. And we really ramped up the student involvement, including student teaching assistantships, which is something that we've never done quite yet at KVOCC. So I'm looking forward to that. So in conclusion, intriguing preliminary findings. I'm confident that we'll be able to have a really valuable manuscript to add to the scholarly literature. All of our goals have been met or exceeded. And again, being able to solve this problem for the community has really been the most heartwarming part of this. And I'd like to just acknowledge all the partners again and the funding source, USDA, NIFA. The award number is on the screen. I've emailed my slides to Kathy for anyone who's interested. So I think it's time for me to stop talking and opening up to questions.